Hello, my name's Daniel Luckman. I'm a fifth-year computer engineering student at the University of Florida. I will be in charge of creating a stylized 3D animated character as well as streaming our application to a website.
My name's Caleb Johnson. I'm also a fifth-year computer engineering student, and I'll be in charge of the back-end development and integrating the project through Unity.
I have experience with game development on Unity game engine as well as making web applications. Both these skills will be utilized in our project because we will be running our code on Unity as well as streaming our software in real time online.
So I have some experience writing in JavaScript and C#, which will be very important to this project because the majority of the back-end features will be written in these languages.
Over the course of this semester, I started to set up the project repository as well as setting up the Unity project. I have done a lot of research on OpenFace. OpenFace is an open source facial recognition model that we will be using to read 2D facial landmarks before being converted to our 3D animated character.
During the semester, I compiled a list of the software we'll be using, and I've downloaded and began getting familiar with it and its uses. I've also started getting more familiar with C# and JavaScript programming.
Algorithms that can interpret 2D data and convert it into 3D animation are not straightforward and require machine learning and large amounts of training data. Fortunately, source code for such algorithms has recently become available. Animating 3D characters in real time, however, has remained largely unaddressed in academia and open source projects. For our project, we will address this issue by leveraging a game engine, a 3D character model, and a camera data stream. Our objective for this project will be to attempt to create a stylized 3D avatar that can mimic the head and facial gestures of the user in a real-time web application.
While there's a large demand for real-time live video to 3D animation, there are very few open source applications available to address this demand. We aim to create an easy-to-use application to be used in various implementations. This project will also give us an opportunity to learn more about using 3D game engines, as well as 3D character modeling and web application development. The program will start with the user streaming video from their webcam, and OpenFace will record information from the video about the user's facial expressions, such as how much their eyebrows are raised or how much their mouth is open. We will be using Unity to import this information, as well as to import a 3D character model. Unity will translate the information from OpenFace and apply it to the 3D model to drive its animation. Finally, Unity will export this with WebGL to be used on web applications.
Our biggest hurdle is that this is our first time working on a project using real-time facial recognition and tracking. So we will need to conduct research on this topic to gain a better understanding of what to expect for creating it. Likewise, we have never created a character model using 3D software, such as 3ds Max before. To address this, we plan to watch tutorials as well as receive assistance from friends who do have experience using these softwares.
We'll be creating a 2D facial landmark to 3D facial animation converter. This software will calculate a 3D pose using a 2D object in real time. This works by taking a few points on the face of the image, such as the corner of the eyes, the tip of the nose, the corner of the mouth, and many other facial points. Then it transfers these points to a 3D location of the same vector. We'll be transferring these to a 3D animation which will be streamed on a web application.
The majority of the information comes from the first source, which is a publication made by OpenFace's creators about the software. In it, they describe the features within their toolkit and the benefits this technology can provide. We also got information on head post estimation from an OpenCV tutorial and information about human-computer interaction from the Interactive Design Foundation. Lastly, there's also some information from psychological bulletins about how facial expressions are important to human communication.